Hey Algebra 2 friends, here we are in section 10.4. We're looking at common logarithm. Our two vocabulary words today refer to the common log. The first one is the common logarithm. And basically, we know that we've got log base b of some number c is equal to some answer d such that b to the d power equals c. Well, the common log is the log when the base is 10. So in these types of problems, you're thinking about what 10 to what power will give you the value here. So the common logarithm is log base 10 of a number, but the way we write it is we write it as just log like that. And the reason why it's done like that, if you look on your calculators, on your phone, you will see log, and that is like so that's why it's called the common log, because it is the log. Now, a long time ago, we used to have the power to, we didn't have the power to change the base easily, so it was nice to have access to one log, and we'll talk a little bit about that. Change the base of like of a logarithmic expression. Okay, thank you for being with me. So check this out. So the change of base formula, let's say I have some log base b of c. The change of base formula is basically this: log of any new base that you prefer of c over log of that same new base of the lowercase b. And so what this gives us the power of doing, if we have this standard log in our calculator, is to say, oh, if I had to calculate, for instance, log base 3 of 7, I would just say log base 10 of 7, or the common log of 7, rather, sorry about that, over the common log of 3, and I would get the correct answer. And when I do that, I get this value. I get 1.7712, which is log base 10 of 7 divided by log base 10 of 3, which means that if I were to take 3 and raise it to the power of 1.77, I would get 7. All right, hopefully that kind of makes sense. We'll be doing examples like this in a moment. So let me get back to our screen and let's go ahead and take a look at this first one. So, well, this isn't really an example. This is going to help us with one of the examples. I just wanted to talk about it. I did ask you in your assignment to take a look at this. And so basically, we are looking at this pH scale, and we're seeing that the pH scale, the values on the pH scale are derived from a base 10 log. So I want you to make sure and take a look at that in your textbook. I think it's on page 543. If not, pause it here. Make sure you look at it so that you can rightfully do the problem that relates to this. Okay, so this first example is really, can you use a calculator in some way? And so can you use a calculator to evaluate the expression to 4 decimal places? And so your job is literally to plug in log of 3 and log of 0.2. Now, some calculators work a little bit different. You might have to put 3 in and then push the log button to get your answer. Please play with it, and right now, like, go get your calculator, pause me, go get your calculator if you don't have it, and make sure you see if you're using another Desmos or some other online thing, make sure you understand how to use it so that when you do log of 3 and log of 0.2, you get these values here, 0.4771 and negative 0.6990. All right, so that's all this example is about. So I thought we'd just do that quickly. Let's look at example 2. Here in example 2, we're checking out how the logarithmic equation is being used in this case with the Richter scale and earthquakes. Okay, the amount of energy E in ergs that an earthquake releases is related to its Richter scale magnitude M. By the equation log of E, log base, that the common log of E is equal to 11.8 plus 1.5 M. The Chilean earthquake of 1960 measured 8.5 on the Richter scale. How much energy was released? So I don't know about you, sometimes I get mixed up with the variables, so I need to keep them straight. E is the energy in this equation, and it's measured in ergs, and M refers to the magnitude, which is the Richter scale measurement, okay? So this is the Richter scale measurement. All right. So now that we've gotten that kind of straightened out, let's see what we're looking for. We're looking for how much energy is released or was released. And so that means we are looking for E. I'm going to highlight E because we need to solve for E. And we are given M the information that it's 8.5. So now let's plug all of this into our equation where common log of E is equal to 11.8 plus 1.5 times 8.5. So after multiplying this and adding it together, we get that log base E is equal to, I keep saying log base E, y'all, common log of E is equal to 24.55. Okay, so if that's the case, how do we solve for this value? What does it mean? Well, we remember that the common log is log base 10. So this is really log base 10 of some number is equal to 24.55. So how would we solve this? Well, we know that we can rewrite this as an exponential form, in its exponential form, as 10 to the 24.55 is equal to E. And so there it is. We've solved it. So I'm sure we can come up with a calculatable value where we've got a bunch of zeros and things, but we're going to leave it like this. All right? How can we solve something like this in example 3? Now, usually we would try to make things have the same base. If we had a situation where 3 to a power is equal to some other number, we try to make it the same base. But we can't do that here. And when we can't do that, we have to use log laws. We have to use ideas that we have been introduced to. So we didn't derive the change of base formula exactly, but this problem is going to show us how to derive it. So if I had 3x is equal to 11, what I could do is take the log of both sides, because if this number is equal to this number, which the problem implies, then the log or the common log of both of those numbers have to be equal as well, okay? So the common log of 3x is equal to the common log of 11. Remember my exponential law where I can write this exponent as a coefficient of the entire logarithmic expression? That's what I'm going to employ here. And then the next thing I'm going to do is divide both sides by log of 3. And so when I do that, common log of 3, this is what I get. X is equal to log of 11 divided by log of 3, which is the change of base formula. And here's why we can see it as a change of base formula. I'm going to actually calculate this, but I just want to do this so we're together. Remember, I can write this as an actual logarithmic expression. So what happens here, it would be log base 3 of 11 equals x. That's what we were looking for. But I'm also saying that x is equal to this. Notice that we took the log base 10 of the large number and then log base 10 of the base, and then we put them over each other to get our answer. So when I calculate this in my calculator, we get that x is equal to approximately 2.187, okay? And so that means that 3 to the 2.187 power, a little bit more than 2, will give us 11. Here in example 4, we're going to take the log of both sides. As we know that if these two are unequal, where 5 to the 3y is less than 8 to the y minus 1, then log, base 10, common log, of 5 to the 3y power has to be less than the common log of 8 to the y minus 1 power. So when I take the log of both sides, you remember the log law that gives me the power to write this exponent as a coefficient. I get 3y is equal to log base 5, common log of 5, which is less than y minus 1, that's the exponent there, times log of 8, common log of 8. And at this point, I want to distribute through. You can do this a couple ways, but I'm going to distribute through so we can kind of plug everything into our calculator at the end. We could join y terms together and divide both sides by log base 5, or common log of 5, but we won't do that. So I'm going to distribute that through so I can get all my y terms, pull it to one side. You'll see. So 3y times log of 5, common log of 5, is equal to y times the common log of 8 minus the common log of 8. And then if I bring this all over to the other side, I get all of this together. 3y log of 5 minus y times log, common log of 8. and that's going to be less than minus the log of 8. Let's see if I can straighten this out. Okay, that's a little better. And so at this point, since I have all the y terms over on one side, I can factor out the y term. And that was the goal, because we want to try to find the most simple way to write this. So when I factor out a y out of that term, this is what I'm left with. Hopefully this is making sense, everybody. And this is less than negative the common log of 8. And so now you can see that all I have to do is bring everything over to one side by dividing both sides by this expression here. I'm left with minus the common log of 8 over 3 times the common log of 5 minus the common log of 8. And so now this is really just a calculator pusher kind of move. You're going to plug that into your calculator and we'll get that y has to be less than a couple values here. I hope you don't feel bad that I'm cheating us out of the experience of pushing calculator buttons. I just don't want our video to be too long. 0.7564, negative 0.7564. And of course we can plug this back in, and feel free to do so. Plug it back in and check to make sure that it makes sense, that it satisfies your answer. And when you check it, it will work. All right, and so the final problem is a change of base formula problem, which you guys already have done, but you should probably pause this and see if you can do it yourself. We're going to use the common logarithm to do the change of base. That's a 25 and not a 24. I know somebody's screaming at their screen now. Calm down, child. Okay, so at this point, we should know that this is all we have to do. Take the common log of this number and the common log of this number and plug that into our calculators and divide. And with that, we end up with 2.3219. There we go. Put it all there as the value. So what are we trying to figure out? 4 to what power equals 25? And it wouldn't be 4 to the third since that's 65. It would be 4 to the second because that's 6. It wouldn't be 4 to the second because that's 16. So you know the number had to be between 2 and 3. With that, my friends, I'm done. Let me know if there's any questions. I look forward to talking to you guys soon. Please take care and be well. Bye-bye.